In this video, we're going to compute the area bounded by the curves y equals 2, y equals the natural log of x, the y-axis, and the x-axis. Now, if you started thinking through this problem using the strategies in the previous video, you'll notice that there are two bottom boundaries, and so that would force you to set up two distinct integrals if you were to integrate with respect to x. We're going to simplify matters by setting up an integral with respect to y. And notice that there's only one rightmost boundary and only one leftmost boundary. So that is why if we integrate with respect to the y variable, we only have to use one integral as opposed to two. So we are going to be integrating with respect to y. Okay. And what are the limits of integration? Well, y starts at 0 and it grows until we hit this upper boundary, y equals 2. So the limits of integration are just 0 and 2. What will be the integrand? So in this problem, we just need to figure out how to write down these horizontal lengths, and that's just given by the relationship y equals the natural log of x. However, the natural log of x is not the integrand. We're going to need to rewrite this equation y equals natural log of x in terms of a function of y. In other words, we have to invert this relationship and write x as some function of y. And this is pretty straightforward if you remember the inverse function relationship between the natural log function and e to the x. So if we start off writing y equals the natural log of x, I need to get x by itself. Take this equation and solve for x. And the way to do that is just raise e to the y power, and that's going to be equal to e to the natural log of x. And now the natural log function is an inverse function to e to the x, so the right side simplifies to x, and we now have x expressed as a function of y. This is also our integrand, e to the y. And that's the integral. Now, if our leftmost boundary wasn't just the function x equals 0, but with some more complicated shape, then we would have to be subtracting the formula for our left boundary. But as it is, right now it's just the constant function x equals 0. Okay, so let's solve this integral using the fundamental theorem of calculus. We know that e to the y has antiderivative e to the y. Again, we're integrating with respect to y. And now we're going to evaluate that at the endpoints, 0 to 2. So we have e squared minus e to the 0 power, and we get e squared minus 1. And that is the area of the shaded region.